Hey everyone, welcome back to this course, Econometrics. Today we'll be discussing Module 5, which is panel data econometrics. By way of module objectives, by the end of this module, students should be able to explain what panel data are and why they are valuable in economics, distinguish between pooled OLS, fixed effect, random effect, first differences, and two-way fixed effect models. Derive and interpret the fixed effects estimator and explain how it handles time invariant unobserved heterogeneity. State the assumptions needed for fixed effect to deliver unbiased and consistent estimates. Derive the random effect model as a variance component structure, that is, explain GLS estimation. Compare fixed effect and random effect in terms of assumption, efficiency, and interpretation. Conduct and estimate the Hausman test for choosing between fixed and random effect and understand its logic as a test of correlation between regressors and unit effect. Explain why dynamic panels models require GMM methods. Derive the Nico bias intuition and implement the difference GMM systems. Use and interpret dynamic panel diagnostics. Then design, estimate, report panel regressions responsibly. By way of introduction, panel data, also called longitudinal data, combines cross-sectional time series information by observing the same economic units repeatedly over time. A panel data has two dimensions. That's the cross-sectional dimension, e.g. household firms, and the time dimension, that is periods, times, quarter, month. This structure is central in modern applied econometrics because many economic questions are fundamentally about changes, how wages evolve as workers gain experience, how firms adjust investment after policy reforms, how poverty changes as households face shocks, and how productivity responds to technology adoption. Compare the cross-sectional data. Panel data allows researchers to control for unobserved time invariant differences across units. These unobserved factors often bias simple regression because they influence both the outcome and the explanatory variable. Panel methods address this through fixed effects or related transformations that remove unit-specific time invariant components, shaping casual interpretation under credible assumptions. Compared with pure time series data, panel data provide many units observed simultaneously, offering more variation, improved precision, and the ability to study heterogeneity across units. For policy evaluation, panels are particularly valuable because reforms often occur at different times across regions or groups, and outcomes can be compared before and after changes within the same unit. However, panel econometrics introduces new issues. We distinguish unit time within unit over time, variation from between unit variation, handle unbalanced panels, consider serial correlation and heterodicity in errors, address cross-sectional dependence, shocks that affect many units simultaneously. And for dynamic models, we deal with heterogeneity created by lag-dependent variables. This module provides a rigorous and applied foundation in panel data methods with a focus on fixed effects, random effects, model choice using the Hausman test, and dynamic panel methods estimated by the generalized method of moments, GMM. What are panel data? Panel data are longitudinal data that observe the same economic unit across multiple time periods. A panel data set has two dimensions, like I said, the cross-sectional and the time dimension. Why panel data are valuable in economics? Many economic questions involve change, wage growth, policy reforms, productivity adjustment, poverty transitions, firm investment responses. Panel data allows us to control for unobserved time invariant characteristics, ability, culture, geography, that's bias, cross-sectional regression. By comparing each unit to themselves over time, panel strengthens casual interpretation under credible assumptions. Let's look at some of the key terminologies. What is a balance panel? A balance panel is where every unit observed in the time period. On balance panel, some units are missing in the period. Why for unit effect? Time invariant unobserved heterogeneity. While the time effect is the period specific shock common to all units. Within variation, this is changes over time within a unit. Between variation, this is the differences across units in their averages. Now let's look at the fixed effects FM model. This is the equation. AI, that is this particular one here, the subscript I, captures unobserved time invariant characteristics that may be correlated with X. FE eliminates A using within unit variation. Identification comes only from changes within each unit over time. Why FE matter? If A subscript I is correlated with X, pooled OLS is biased because omitted characteristics affect both Y and X. Fixed effect compares each unit to itself over time, eliminating time invariant biases. An example is a worker's ability affecting wages and training participation. FE isolate the within worker training effect. Now let's look at the within transformation, the meaning. Then this is the equation. Subtracting unit averages, remove the AI completely. After the meaning, OLS applied to transform data use the FE estimator. Time invariant variables drop out because they do not vary within units. Let's look at the two-way fixed effect. Many applications require controlling for time effects, e.g. macro shocks. The two-way FE, this is the equation for two-way FE. This controls for both unit-specific and time-specific unobserved factors. Let's look at some of the assumptions from FE consistency. There is linearity in parameters. There is no perfect multicollinearity. There is sufficiency within variations. Then there's strict exogeneity. Then there's large N asymptotics typically assumed. Let's look at some of the strict exogeneity explained. Strict exogeneity means shock U subscript IT do not affect past, current, or future values of X. It rules out feedback effect and dynamic heterogeneity. Violation occurs if policy responds to shock or if regressors adjust after outcome changes. What FE cannot estimate? Time invariant regressors are absorbed by AI. Regressors within variation produce imprecise estimates. Time varying omitted variables can still bias FE. Now let's look at cluster standard errors in panels. Errors are often serially correlated within units. Cluster robot standard errors remain valid under arbitrary within unit correlation. Standard practices, cluster by units, large N is required. Then for random effects model, ROE treats AI as random and correlated with X, T. What are some of the key assumptions? ROE uses both within and between variations that via GLS. Let's look at the random effect versus the fixed effect for a comparison. The FE allows correlation between X and I. ROE does not. ROE estimate time invariant regressors, FE cannot. ROE assumptions hold. If ROE assumptions hold, ROE is more efficient than FE. Let's look at quasi-demeaning in ROE. ROE applies a weighted transformation, subtracting the theta times unit mean. If unit heterogeneity is large, theta approaches 1, that is close to FE. If heterogeneity is small, theta approaches 0, that is close to put OLS. When OLS is often problematic, this is if regressors are correlated within unit effects, that is the ability correlated with income, for example. ROE becomes inconsistent. This assumption is often unrealistic in economics. FE is safer when correlation is suspected. Let's look at the Haussmann test. This is the formula for Haussmann. If estimates differ significantly, ROE is inconsistent and FE preferred. Haussmann tests correlation between regressors, and unit effect. Let's look at intuition of the Haussmann logic. Under the null, both arrow FE and arrow E are consistent and arrow E is efficient. Under the alternative for hypothesis, arrow E is biased while FE remains consistent. Large differences between estimates indicate violation of arrow E orthogonality. Let's look at the dynamic panel model. This is the formula where lag-dependent variable introduce persistency. FE applied directly lead to Nico biases. Bias persists when T is small. Nico bias intuition. After demeaning, the lag-dependent variable becomes correlated with transform error. This creates endogeneity, even if original errors are not serially correlated. Biases does not vanish as N increases when T is fixed. Generalized method of moment, GMM. GMM uses moment conditions, that is instrument uncorrelated with error. In dynamics panel, deeper lag serves as instrument. Difference GMM and system GMM are common implementations of this. Let's look at difference GMM given by the Arellano bond. This is the formula. This is changed in Y subscript IT. This IT means this panel data we are dealing with. This is a subscript. Now, first differencing removes AI. The lag levels valid if errors have no serial correlation. For the system GMM, this add levels equations to improve efficiency. It uses lag differences as instrument for level equation. It is useful when time variables are highly persistent. Let's look at dynamic panel diagnostics. ARO1 tests expected significance differences. ARO2 test should be significant. Hazard or the SIGAN test evaluates instrument validity. Then avoid instrument proliferation where the N is greater than instrument. Now, by way of conclusion, panel data econometrics strengthens empirical economic analysis by exploiting repeated observation on the same units. Its main advantage is control for unobserved time invariant heterogeneity that would otherwise bias estimates. The fixed model achieves this by removing unit effect through within transformation, delivering consistent estimates when strict heterogeneity holds and when appropriate robust differences is used. Random effects provide an efficient alternative and allows estimations of time invariant regressors, but only under the strong orthogonality assumption that unit effects are uncorrelated with regressors. The Haussmann test formalizes the choice by checking whether FE and ROE estimate beyond sampling variations. When outcomes are dynamic and depend on past values, FE effects become biased in short panels. Dynamic panels, GMM methods, that is difference GMM and assisted GMM, offer a principal solution by using lagged variables as instruments under clear moment conditions. Good practice requires disciplined instrument choice, robust standard errors, and careful diagnostics. Across all panels, credible economic interpretation depends not only on estimation techniques, but also on research design, data quality, transparent discussion of many threat to casualty. That is the end for module 5. I'll see you in module 6.